Question 10 says a guy wire attached to a vertical pole of height 18 meters is 24 meters long and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut? So let me explain this problem to you. Let me help you visualize this problem because the language might seem a bit complicated. So here's a sketch of a pole that I've drawn that we will use to solve this problem. We are told that the pole has a height of 18 meters. Okay, so this pole has a height of 18 meters. Now a guy wire is attached to this pole. A guy wire is a wire which is used to balance tall structures. So we have a guy wire that is attached to this pole. So imagine a wire attached to the top of the pole like this, and this has a stake attached to the other end. This stake here that you see, this is attached to the other end of the wire. This stake is basically will be driven into the ground to make the wire taut. So imagine a situation like this where the stake is driven into the ground like this and the wire becomes completely taut. Taut means completely straight. So it's not slack. There's no slack in the wire. It's completely straight. So what the question is really asking us is how far from the base of the pole should the stake be driven so that the wire will be taut. So basically what should this distance be? The distance of the stake from the base of the pole so that the wire becomes completely taut. Okay, and we know that the wire is 24 meters long. So this length is 24 meters. And now you can see that this is a simple problem based on the Pythagoras theorem because we have a right angled triangle here in which two sides are known. So let's label the points. So let's label the stake, the position of the stake as point A, the base of the pole as point B, and the top of the pole as point C. So triangle ABC, as you can see, is a right angled triangle in which AC, the hypotenuse, is 24 meters. Then BC, the height of the pole, is 18 meters. And we have to find AB, the distance of the stake from the base of the pole. Correct? So now let's apply the Pythagoras theorem to triangle ABC. So using the Pythagoras theorem, we will have AB square. AB square will be equal to AC square minus BC square. Now let's plug in the value. AC is 24 meters, so we get 24 meters whole square, minus BC is 18 meters, so we get minus 18 meters whole square. 24 square is 576, so we get 576 meters square, minus 18 square is 324, so we get 324 meters square. And 576 minus 324 is 252. So 252 meter square. So we get AB square as 252 meters square. So now we need to take the square root. So AB will be equal to root of 252 meters. And now let's calculate the square root. To calculate the square root, let's prime factorize 252. Okay, so 252, let's prime factorize this. So we divide it by 2. This gives us 126. Divide by 2 again. This gives us 63. Then we divide by 3. So that gives us 21. And then we divide by 3 again. That gives us 7. And finally we divide by 7. So that gives us 1. So 252 in prime factorized form is 2 square into 3 square into 7. So what will we get if we take the square root of this thing? So we will get root of 252 will be 1 repetition of 2 and then 1 repetition of 3, and then because 7 occurs only once, we will have to write root of 7. So 2 into 3 into root 7 meters, or 6 root 7 meters. This is the answer. So the distance of the stake from the ground, from the base of the pole, should be 6 root 7 meters. This is the answer for question number 10. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.